everyone, welcome back to the another episode of Learn DSA with Sakshi. If you are new here, I am Sakshi Labar and we are conducting a series of Learn DSA with Sakshi. And today we are diving into something very exciting, that is linked list. Whether you are just starting with data structure or looking to something fresh your knowledge, then this video will be very helpful. Now, I know that linked list can be very complex in the start, but trust me, once you break down it into step by step, then it all makes senses. And in this video, we'll actually do the same. But before going to the dynamic linked list, we are actually use the memory location. We are going to look at some fundamental problems so that it can build a groundwork for you. So grab your notebook and let's get started. So today we'll write the three programs. So first one is used for the functions. So we'll write how to use functions in the linked list, and then we'll update this first program, and we'll use the typedef so that we can simplify our linked list code. And in the end, there is the interesting part that we are going to use, or we are creating today, the dynamic linked list. And in this, we are seeing the insert first logic. So these are the topics. So make sure you stay with me till the end. So let's get started. Open your VS Code, then go to your desired folder and name it a program as program4.c. So in this first program, we are going to write the functions. For that, I am copying the previous code. And here is a quick revision for this code. Here we are including the header file. Then we define the structure node here, in which the two members are the data and pointer next. And then in the main function, we define the object of the struct node, which is called first. Actually, this is the pointer first, and here we it assigned as the null. Then here we are creating the three objects of the structure, and then we assigning data to that object, that is 11, 51, and 101. And here is the linking part, how we are linking this object with each other. So we link by the dot next. So object one dot next equal to end of object two, and similarly this. And here first equal to end of object, we are connecting it to object. And for the printing purpose, for display, we write this. So first print statement will display the 11, second will display 51, and third will be 101. So now we just add, how we see how to add functions in this program. So it's not very difficult. So after the structure node, just write one void demo1 function, right? So here is our first function, and similarly we write second function also, void demo2. Now, as this function is not giving anything and we are just for the sake of understanding writing it, so we define its data type as void, and then the parameters to it are the struct node star head, and here struct node star head. So now we are just only defining these two functions, and so the very first function, that is the void demo1 struct node star head, this receives a copy of the head pointer as it is the star head. So it can traverse the list but cannot actually modify the head in the main function, right? Whereas if you can see in the demo2, where we write the struct node star head, this receives the address of the pointer, so it can change the actual head in the main, right? So this is useful when we want to insert or delete node and modify the list. So we make functions like this for our insertion and deletion. And this teaches us that in the first function, structure pointer is used, and in the second, pointer to pointer is used. And this is very important for the dynamic memory. Now we'll just complete the program by calling names. So So how to call it? Just write function and add parameter first. Similarly, demo2, and here we can and of first, not only first, because it is pointer to pointer. And just save your program. And this is how we can insert function into the linked list. So if you compile and run this program, you will get the same output as the previous that the program 3 gives. As we just defined the function name and its parameter here, and not actually doing the logic here. So I can give you a demo of that. So here I run the program 4, and you can see here that it gives the output as 1159.101, which is same as the program 3. So this is all about how we insert functions and calling it, right? Now let's move to the second program. So we'll give it a name as program5.c. Okay, now we are doing the same thing here. Means it is same as the fourth program, but with the more clear syntax. So this is like us just giving nickname or aliases for the complex type. So I just want to write here that in our program for the node, we are going to write node for the struct node. It is just as the nickname for something, another name, which is very complex. And I gave us the idea of this in the previous video as well. So for p node, struct node start and pp node, struct node, struct node starts. Right. So this helps when we write the functions like void demo p node head. So So in the node, we don't need to write the struct node or struct node star or struct node star star as it is lengthy. So instead of this, we can write node, p node, and pp node. Now let's write the code with fresh. Don't copy and paste it, because if you do it, you won't be able to understand it very clearly. So write it down from the scratch. So hashtag header file, then second header file, struct node. So it is as similar. It is similar as the previous one. Then here we are doing typedef. So write typedef. Make sure you write it correctly. Typedef. Then struct node. For struct node, what we are going to write? We are going to write node, right? So write node. Similarly, typedef, struct node, and struct node star. For struct node star, we are going to write p node. And then similarly for the third one, struct node star star, pp node. So this is how we do the aliasing, or you can say typedef. Now we'll write function here, void demo1 and void demo2, like the last program. If you can see in the last program, we write here struct node star head. Now we are defining type def here. So what can we write here? Yes, we can write it here as p node head, because for struct node star we can write p node, right? So it will be p node head, and for the struct node star star we can write pp node head. So just write it pp node head. So this is how we are doing the aliasing. Then into main. Similarly, in the main program, we write struct node star first equal to null. So it will be p node first is equal to null. Then Then what we write? Struct struct node. For the struct node, we use node. So write node obj1, similarly node obj2, then node obj3. Then object.data it is same. So just copy this one because it will be same. Then first is equal to and of obj connecting obj1, connecting it with the object1, then calling your functions. So demo first and then demo second. Return 0. So this is how we write our code with much clearer and better than the previous one by using the typedef. Right. Now just save your program. Typedef is optional, so you can write if you want, but it is great for reducing the code cluster and is especially using the large projects or when teaching for the beginners. It just makes your code looks more simpler and clearer than the previous one. So this is about the typedef. Now we'll move to the third and most important part, that is the dynamic linked list using the insert first. So don't without wasting time, just write program 6.c. And here is the code we are writing our first function of the linked list. If you can remember, we taught us in the previous video. So here is the first function, and we are writing the logic for the linked list for insert first in this code. So now we are moving from the static linked list to dynamic linked list. This means we are not manually creating or fixed nodes anymore. Instead, we'll do dynamic and we allocate memory, then insert new node at the beginning, and then further displaying the whole linked list. So let's get started. So starting with the header file. Now this second header file is used for the malloc function, which we are going to use in the program. Then our main function, then we are going to define the structure node and its type there. It is as same as the previous one. So just copy this and paste it here. Now write the function void insert first. Why its data type is void? Because it is not returning anything. So it is void insert first. Right. Now what will be the parameters for here? As we are inserting the elements means we are manipulating the linked list. So we had to write the pp node, right? Pp node head, because we want to modify the original head pointer from the main function. Imagine, or let's say, if we just pass the p node head to single pointer, the function would only get a copy of the pointer, and any changes made to it wouldn't reflect in the main function, right? So that's why we are passing the pp node here as the first parameter, and then for holding its means data, we are using the int number. So these two will be the parameters for our insert first function. Insert first means if there is not a node in the linked list, then we are going to insert a new node. So for this, we are giving name it as new node. So new n, and to allocate a memory for it, we are using the malloc function here. So how to assign it? Just type node, then malloc size of node, right? So this is the way of dynamically allocating memory for a new node using the malloc function. Then we assign the value passed number to the new node's data. So for this, we'll write new and data is equal to number. So we are just passing this number to this new node. And then it is the first. Then what's about the next? Then new and next. And firstly, we assume it is as null. So assign null to it. Now we are checking the condition. If our linked list is empty or not. If it is empty, then make new node as the first head. Or if it not, then else condition will introduce it. So for this, we'll write the if else part here. I hope you are understanding it. So write if gives condition. So what will be the condition? If star head equal to null, is star head equal to null, then means if linked list is empty, then make star head as the new node. So star head is equal to new node. So this is the first condition. And what will be the else condition? If it is not a empty linked list, then make the new and next equal to star head. And then star head equal to new and star head equal to new and. In this way, we make a new node if it is not the empty linked list, right? So yeah, this is about the logic of the insert first. I'll explain it one more time, but before that, just complete the remaining code. So in the main function, write p node first is equal to null. Then call your function. So insert first and kind of first because modified in this. So 51. Then 51, 21, and then 11. So it will first insert 51 as its first node. Then as 51 is there, then before 51 it will insert 21, and before 21 it will insert the 11. So our linked list will look like 11, 21, and then 51. So as of now, this is the whole program, and we are not displaying it here anything because we don't write display function yet. When we write the display function, that time we are uh, displaying it on the command prompt. So what does the insert first do? I'll explain it one more time. So if you don't understand, uh, now just concentrate on it. So as the word name say, insert first means insert in the beginning of the single linked list. So imagine a linked list like a chain of boxes, and each box has the data and a pointer that is pointing toward the next box, right? When we do the insert first, we are creating a new box and putting it in the front of the chain. So that is what actually insert first is. And then pp node head, its parameter, we pass the address of the head pointer, so we can actually change the starting of the linked list. If we write here p node head, we just make a copy of it, and we are not actually passing or change the starting point of the linked list. And then int number means this is the number we want to store in the new node. So for this, we write int node. Then we use malloc to dynamically allocate memory for the new node, and new n is now a new pointer to newly created node in the heap memory. Then we assign the given number to nodes data. Then we initialize the next pointer to null for now. And then we'll check the condition. If the linked list is empty, the head is null, then we'll simply create new node, make new n as the first node. And if it's not, then in the else part, we write new n next equal to head. So we point new n next to the current first node. Then move the head point to the new n. So this makes new n the first node and the old node come after it. So this is the logic of the insert first. To visualize this, let's draw a diagram of it. So what we said for insert first and of first 51. So it will insert 51. So this will be our new node, new n, its data and its pointer. So here is 51, and then here is null, right? Then we say insert first 21. So it will insert before 51 because as the linked list is not empty. So what is our logic here? If the linked list is not empty, means else part, then new and next equal to star head and star head equal to new and. So it will look like this. Now this is our new and. And it will be 21 and it holds the address of this 51. And in the last we say insert first 11. So it will insert 11 in the first, insert first. So it is actually inserting at the first position and then the address of the this new node. Now this will become our new node. So now this is our new node and this is how it is connecting with each other. And if its address is 100, it's 100, then it's 200 and 300, then it will take as 200, then 300. So this is the visual representation of how we dynamically create linked lists, how the new end gets updated each time by inserting the node at the first position. And in this way, our linked list is created. So congratulations, your linked list is created and it is dynamically one, not static one. So this is all about the linked list creation. In the next video, we will see the display logic and delete class logic, how we insert and delete and how we display it in actual output. So this is all about the linked list creation. So just summarize this video. So till now we have covered the basics of static linked list, then simplified code using the typedef, and then finally took it to the next level with dynamic memory allocation. These three programs build on each other, and understanding them will help you with any type of linked list operations from insertion to deletion. Um, Now, if you can see, if I can directly write the sixth program, then you will get confused or it will maybe difficult to understand for you that what is type def, what is insert first, what is p node, what is new and how we are connecting to it, right? So for this, we create programs from the basics from program 1 until program 5. It is the basic for the linked list. And in the sixth program, we actually create our dynamic linked list. So the understanding of program C would be much more difficult if we don't go from first to the sixth program. So in real world application, this concept is very critical because it follows you to efficiently manage memory and work with large data set. So that's all for today. In the next video, we will deeper go into another linked list operations like the deletion of nodes, then traversal and display. So stay tuned for that. And if you found this video helpful, don't forget to like, share, and subscribe. Let me know in the comments if you have any questions regarding the same. And thanks for watching.